Welcome everyone to my new lecture. We are going to learn about electrical resistance. Okay, so electrical resistance of an electrical conductor is a measure of the difficulty to pass an electric current through that conductor. Every conductors and every resistors have electrical resistance. Even your body is an electrical conductor, but you also have resistance. Your body doesn't want to have electrical current flowing through itself. Also wires, conductors, insulators, semiconductors, and so on and so on. So the formula for the electrical resistance is R is equal to specific electrical resistance times the length of the wire divided by the cross-sectional area of the wire. So you can see when you have, okay, so this specific electrical resistance is always a given. You will always get in your examples what is the electrical resistance, specific electrical resistance of that material. Every material is different by itself. So the longer wire you have, the more electrical resistance, the more electrical resistance you will have, and you won't have that much flow of the electrical current. But in my next lecture, in Ohm's law, you will see the connection between the electrical current, electrical charge, and the electrical resistance. So now we're going to just learn about the electrical resistance. And if you have a wider wire, you will have less electrical resistance. So if you have a wider wire, like so, you will have more electrical current flowing through that wire. So that is the first formula you have to know. This here. Here, and we are going to learn. We are going to have some examples, and we are going to do. Okay, so that is the first case. But electrical resistance also depends on the temperature. So if you have if you have more temperature, if it's hotter outside, you will have, or inside, also electrical current will give you temperature. So the electric resistance is going to be a lot higher. And here you have a formula. R1 is equal to R0. I forgot how you call this stuff. 1 plus temperature coefficient. First, the temperature of the first electrical resistance minus the electric temperature of this electrical resistance. So the R1 is the electrical resistance by temperature T1. We are going to, because I am from Europe, of course, and the unit for this is Celsius degrees for temperature. If you are in America, I think that you have Fahrenheit, but I don't know how to do it. Fahrenheit, so I will do with Celsius. Also, it's in the same principle. Temperature coefficient, that's also given. One material has a higher temperature coefficient of resistance. Some has less. It all depends. So let us do some examples, and you will see that it's not really hard to do this. I also forgot. Okay, specific electrical resistance is measured in ohms millimeters squared per meter. Length of the wire is meter, and the cross-sectional area of the wire we are going to measure it in millimeters squared. Why millimeters? Because usually all wires, all conductors are really thin, so we want to learn it in meters. But also you can learn it in transfer this into meters. It's not that hard. Okay, so you can write all this down. You can you have to learn about, or you want to have notes about this. So pause the video clip, and here we are going to learn some. We are going to do some examples. So I'm going to I'm going to remove all this text. Okay, so the first example, let me just see how it says. What is the electric resistance of a copper wire, length of 3 kilometers and a cross-sectional area of 10 millimeters squared? The specific resistance of copper wire is 0.018 ohms millimeters squared per meter. So we have to measure what is the electric resistance of a wire that is a length of 3 kilometers. Is 3 kilometers. And with a cross-sectional area of 10 millimeters squared, and the specific resistance, specific electrical resistance of a copper wire is 0.018 ohms millimeters squared per meter. Okay, so the formula is electrical resistance, specific electrical resistance times the length be divided by the area. Okay, so now you put all these equations on these numbers into this equation. So the electrical resistance is, specific electrical resistance is 0.018 ohms millimeters squared per meter times, you have to transfer this into meters. That's the that's the basic unit we have to have, so we can calculate what the resistance is. 3 kilometers is 300 meters. In 1 kilometer you have 1,000 meters, and 3 times 1,000 is 3,000 meters. So you have 3,000 meters, and you have 10 millimeters squared. Okay, this is math. This cancel each out, other out. Meters and meters cancel each out. You have ohms, and that's what you have to get to get the electrical resistance. And when you calculate all this, you get 5.4 ohms. So this copper wire will give you the electrical resistance of 5.4 ohms. Okay, let's do another one. What is the length of the copper wire? Or what is the length? Okay, this was what is the length of the copper wire, which has electrical resistance of 15 ohms and an area, cross-sectional area of 4.91 millimeters squared. Okay, so the formula is R equals specific resistance times L divided by A. A is going to go here, and the specific resistance, when you put it on the other side, you will have this situation. L equals A times R divided by specific resistance. Also, this is a copper wire, so the copper wire is always the same. Specific resistance of copper is always the same. So now you have 4.91 millimeters squared times the resistance is 15 ohms divided by 0.018 millimeters squared divided by m. Meters, they cancel each other out. Oh, I forgot ohms here. Ohms and ohms also cancel each other out. Meters is going to get over here because there's a and when you calculate all this, you get 4,120 meters. So that's the length of the wire that has electrical resistance of 15 ohms and an area of 4.91 millimeters squared. And let's do one more with temperatures, and you'll get the point how all this. Now you get how this example, how can you calculate the electrical resistance of, a lot of conductors. And one more, and that will be it. What is the resistance of a copper wire that has a length of 1.5 kilometers? Oh, sorry. And a cross-sectional area of 16 millimeters squared. On the temperature T1 equals 70 degrees Celsius. Okay. Just make okay, so we have to first calculate what is the resistance of. We have one more. Information. The specific resistance of the copper wire on 20 degrees Celsius, so is 0.018 millimeters squared per meter. That is on the temperature of 20 degrees Celsius. So we have to first calculate what is the resistance of the copper wire when it is 20 degrees Celsius, and we will easily learn or calculate what is the electrical resistance of wire when it is 70 degrees Celsius. Also, the temperature coefficient of the copper wire is alpha equals 0.004. Okay, so the R0 is equal to specific resistance times length divided by the area, that is A. This you have to convert it into meters. So you have to have 1.5 times 1000 meters. Why? Because in 1 kilometer you have 1000 meters, and you have, when you calculate all this, you get 1500 meters. And so 0.018 ohms millimeters squared per meter times 1500 meters divided by the cross-sectional area, that is 16 millimeters squared. And when you calculate all this, you get 1.685 ohms. Okay, so the formula for the resistance when you have temperatures is R0, 1 plus temperature coefficient T1 minus T0. So this is T0, because we calculated this when it is 20 degrees Celsius. So next we get 1.685, and of course the temperature coefficient is, the unit is 1 per Celsius, 1 divided by degrees Celsius. 1 plus 0.004, 70 degrees Celsius minus 20 degrees Celsius. We get 1.685. 1 plus 0.004. Oh, I forgot 1 divided by C. 1 degrees Celsius. And we here have to have ohms. So I forgot to put ohms right here. Divided 70 minus 20 is 50 degrees Celsius, and this cancel each other out. You have 0.004 times 50 plus 1 and times this 1.685, and you get 2.05 ohms. Okay, so that was the electrical resistance, how it's measured, how it's calculated. That's all, for this lecture, and see you in my next video where we are going to learn about Ohm's law.